If you want to learn more about logarithms, this is the video for you. Today, we're going to be talking about logarithms. I love logarithms because they're really easy once you actually get the concept in your head. So in this video, I'm going to teach you the concepts you need to understand so that you can be good at logarithms too. First things first though, I have to explain how to pronounce logarithmic notation. Here are 3 logarithms, and I'm going to walk you through how to pronounce each one. This first one here is pronounced log base 3 of 9. This second one is pronounced log base x of 6. And this third one is pronounced log base 8 of 4. So, the first concept you have to understand is that logarithms are just exponents. That's all they are. The logarithm represents an exponent. Let me give you an example. Here is a logarithm here. The log base 3 of 9. And the log base 3 of 9 is just the exponent you have to raise 3 to get 9. Let me say that again. The log base 3 of 9 is just the exponent you have to raise 3 to get 9. So, the log base 3 of 9 is equal to 2, because the exponent you have to raise 3 to get 9 is 2. Does that make sense? If you raise 3 to the second power, you get 9. Therefore, the log base 3 of 9 is just 2. It's so cool. Okay, so the log base 4 of 64 is just the exponent you have to raise 4 to get 64. So it stands to reason that the log base 4 of 64 is equal to 3, because the exponent you have to raise 3 to get 64 is 3. Okay, so we've gone over that. So now let me give you an example problem. Here is my example problem. The log base x of 4 equals 2. Okay, so you're saying this log base x of 4 is the exponent you have to raise x to get 4. So here's what we do. We use the base, answer, and power method. So in this example, this is the base, this is the answer, and this is the power. So if you raise the base to the power, you get the answer. Make sense? So what do you have to raise x to get 2? If you find the square root of both sides, you get rid of the square on the x term, and the square root of 4 is just positive or negative 2. So those are your 2 answers to this equation. Isn't that cool? I like to call this method the BAP method, because that is the acronym for base, answer, and power. B-A-P, BAP. So, if you see a logarithm, all you gotta do is BAP it. So those are really the huge concepts that you have to understand to make logarithms easy. Now before we go into the examples, I'm going to tell you about 2 special logs that you'll see very often when working with logarithms. The first one is called the natural log. You write that by writing ln, as you see up here. The natural logarithm is equivalent to writing the log base e of something. What is e, you ask? Well, don't get too scared, because e is just another constant, just like pi. You know how pi is 3.14159 or whatever the heck it is? Well, e is just 2.718288128. So don't get scared when you see the natural log, it's just another logarithm. The next special logarithm is the log base 10. The log base 10 is written like this. The log of x is the same as writing the log base 10 of x. The thing is, mathematicians wrote the log base 10 of x so often, so they all figured, well, let's just establish that if there's no base written, it's 10. Just like how they got tired of writing the 2 in the square root, because you write the square roots so often. Okay, now that we've established some of the core concepts of logarithms, I want to tell you about the 3 properties of logarithms. So this first one is about the products. If you have 2 things multiplied by each other inside a logarithm, you can split them up into the logs of both of the numbers being multiplied by each other added together. So, for example, the log base 3 of 2x is equal to the log base 3 of 2 plus the log base 3 of x. You can do this backwards too. The log base 4 of 4 plus the log base 4 of 3 is equal to the log base 4 of 4 times 3, or the log base 4 of 12. This second property is the same type of thing, except it's about division. If you have one thing divided by a second thing and a log, you can split it up into the log of the first thing minus the log of the second thing. Quick note here, the base of the log has to stay the same. So, for example, the log base 4 of 4 divided by 3 can be split up into the log base 4 of 4 minus the log base 4 of 3. This can also be done backwards. Okay, this last one is a little bit trickier, but if the number within the logarithm is being raised to a power, you can move the power down to the front and have the number that was the power being multiplied by the logarithm. So the log base 4 of 3 to the 4th power equals 4 times the log base 4 of 3. And guess what I'm going to say next? This one can be done backwards too. 8 times the log base 3 of 2 is equal to the log base 3 of 2 to the 8th power, or the log base 3 of 256. Okay, we're almost through. Now I'm going to talk to you about a few common pitfalls that people run into while they're doing logarithmic problems. The first common pitfall is what I like to call the multiplication issue. Basically, when people see the log base 3 of 4, or say that you're going to find the log of both sides of an equation, they think that it's like multiplying both sides by log or something. Don't fall for this one. Here's how I like to think about what a log actually is. You know how if you have a function, the notation for the function could be something like f of x, or g of x, or h of x? Well, log of x is just another function. Just like f of x is not the same as f times x, log of x is not the same as log times x. You are doing an operation on x. This is the same way with trigonometry. So the sine of x is not sin times x. It is a function sine being operated upon x. The second common pitfall is running into domain issues. The first thing you have to understand about the domain of the log function is that it cannot be equal to 0, and it cannot be anything less than 0. If you look at the graph of the logarithmic function y equals log of x, it doesn't matter what the base is, by the way, you find that it kind of arcs down from the top and then gets very, very, very close to x equals 0, or the y-axis, but never actually touches it. In fact, it will go on into infinity, getting infinitely closer to x equals 0, but never ever touch it. That's because there's a vertical asymptote at the y-axis. The domain of the logarithmic function is from 0 to positive infinity non-inclusive. Non-inclusive means that it will never touch that number. So if you were to look at it on the number line, here's 0, and this is where it kind of almost touches 0 but never really does, and then it goes on into infinity. The range is from negative infinity to positive infinity, so you don't have to worry about that. But don't try to plug anything below or equal to 0 into the logarithmic function, or you will run into problems. Okay, we're almost done. The last thing I'm going to show you is an extra tip: how to plug logarithms with different bases into a calculator. If you look at most calculators, you'll find that you can only plug in the natural log, ln, or the log base 10, which is just log. But there's a special trick that you can use to plug in any base logarithm. Here's what you do. You look at this property of logarithms, which says log base a of x, that's just any base, is equal to the log base b of x divided by the log base b of a. Well, what the heck does that mean? Well, let me give you an example. The log base 3 of x isn't something you can plug into your calculator just willy-nilly, or at least most calculators, but you can use this above property to plug it into your calculator in a sort of roundabout way. You use the natural log, or the log base 10, so that either e or x is in the place of that b variable up there. So here's what it would look like. The natural log of x over the natural log of 3. The base goes into the log on the bottom, and the answer goes into the log on the top. You can do this with any logarithm. So that's it for this video. I hope it was helpful for you guys. Please post any questions you have in the comments section. I'm going to leave you with just a few example problems for you to work through, Then you can head over to the next video to watch me walk through the problems and give you the answers. I hope this has helped you out. I know that with this knowledge, you're going to be good at logarithms. And always remember, you can be good at math. Bye!